Hello, Doctor. This is a video for Milestone 1. My name is Jason Ling Joshun, and I am representing Group 11, which also consists of Zhu Kaijie and Chan Zhijian. This is a video that will be representing about the 4-bit ripple carry adder.
First, we'll be using a schematic diagram to create the half adder. For the logic symbols, we'll be using an AND gate and an XOR gate. Then we'll have two inputs which will be labeled as A and B, and two outputs labeled as C and S. Then we'll connect the input to the gates and the output from the gates to the output. After the circuit is connected, make sure the top level entry is labeled as HA. Then we can run and compile the design. Here is the flow summary. Next, we'll be creating the waveform for the half adder. We'll be inserting the values into the waveform. Set the grid to be on 100 nanosecond per grid. Then set the end time to 400 nanoseconds. For the input A, the input A will have 0011, while input B will have 0101. After that, save it and we can start simulating it. If there's errors in the simulation, switch it to VHDL and remove lower warp from the coding. Then save it and restart the simulation. This is the output waveform for the half adder. Next, we'll be creating the full adder. For it to work, we'll be using the file from the half adder to create a new block diagram. By using two half adder block diagram and then one OR diagram with 3 inputs and 2 outputs. After organizing the circuit, connect all the circuits with a node line. The input will be labeled as A, B, and SIN. For the output, it will be called NS. After it's done, make sure the top level entry is labeled as FA. Save the diagram, and then we can start simulation and compiling the design. This is the flow summary of the full adder. Next, we'll be creating the waveform for the full adder. As usual, we'll be inserting the inputs and the outputs labeled out. Then, we'll be creating the grid size with a 100 interval nanoseconds. And then we'll have an end time of 800 nanoseconds. For A, it will be a count of 400 nanoseconds. For B, it will be a count of 200 nanoseconds. And SYN will be 100 nanoseconds. After it's done, save the file, and then you can start simulating it. If there is an error, just like before, change it to VHDL and remove lower warp from the code. Run the simulation again to get the waveform. This is the output waveform. Next, we'll be creating the 4-bit ripple adder diagram. For this to work, we'll be using the full adder block diagram that we have just created. We'll be using 4 full adder and arranging it accordingly. We'll have 3 inputs which will be labeled as A, B, and SYN, and 2 outputs which will be labeled as chord and S. For the lines that will be connected between the inputs, the full adder diagram, and the output S, we'll be using a bus line. For the rest, it will be connected to a node line. Connect all the circuits and label it all accordingly. After all have been labeled, change the top level entry to ripple carry adder. Then you can compile the design. This is the flow summary for the 4-bit ripple carry adder. And then next we'll be creating the waveform for the 4-bit ripple carry adder. Place down the inputs and then set the grid interval to 100 nanoseconds with the end time being 1000 nanoseconds. Change the value of the input A, B and the output S to hexadecimal. And label it all of it accordingly. After it's done, save the file and then run the simulation. There is an error, so as before, change it to VHDL and remove Novo Volp. For the 4-bit carry adder, this is the output waveform. Thank you.